Hi, it's me again, back for another PC related video. Well, we can test in the Amiga, actually, and that was where I purchased this for. This is a 2 to 4 meg, in fact I think it's 1 to 4 meg, EMS RAM board for an ISA slot, yeah, we've got, an 8-bit ISA slot there. So, I mean, the fact it's not 16-bit, it's, I guess, a limitation. But it's probably going to fit within that range anyway, because I think the way this EMS, it's expanded memory, isn't it? You've got two different types of memory on PC. You've got extended and expanded, and actually you can convert extended into expanded. You need a driver for expanded memory, and it reads it within a 64K window. You have this window that moves around. It may even be in different size blocks, actually, like 4 16K blocks or something like that. I can't honestly remember, but that window pages around the memory map of however much memory you've got. This has got some jumpers or something on here, I think. Anyway, we've got some 7.4 series, all around this here. A discrete logic, no GALs or PALs or CPLDs or anything like that. And then we've got 8, position for 8 of these ASC 4008 SRAMs, I think they are. Yeah, sorry about the jump cut there. I was just about to explain that you need these in pairs because it's 16-bit. It isn't. It's 8-bit. This is the thing. If it was using 16-bit ISA here, you've got the additional 8 bits for 16 bits with ISA. You've got 8 data bits on here. So you could use these in from this position here onwards, a single chip at a time. So if you want 1.5 meg, you could just have 3 chips. If you want 2 meg, 4 chips. 3 meg, 6 chips, etc. And I think there's probably some jumpers to configure this, probably somewhere around here. This particular PCB was manufactured by Dirty PCBs. I had this done at Dirty PCBs, and they've done a really good job. They've even smoothed off and rounded everything here. It's really good. There is an imperfection there you can see on the slot. It's just a bit of solid mass paint, I think, so that'll just wipe off. This was just the first one I got out of the pack, and yeah, I've got a few of these. It was a bit pricey to get these made because it's quite a large board compared to their standard prototype boards, which are cheap. So I think I've got, 10 or so there. A few people on my Discord have asked for 1 or 2 of those. So like Sparks UK, I think, wants one, and Glenn over at CRG. So do check Glenn's channel out, because he may do one of these. And yeah, you get different things out of different videos. In other words, he might build it slightly different, and he might test it slightly different. He might run into different problems. So it's always worth checking out other channels on the same subject material. Yeah, and looking at that table there, we've got EMS page frame base. Yeah, so you can do C000, D000, E000, and then the bottom configuration setting there is invalid. And then you've got EMS IO port base, so 260 to 263, 264 to 267, 268 to 26 something, I can't read what that says there, and 26C. So yeah, there's a few different options of where you might want to fit this in your, your memory map and your address range and stuff within your system. So the original that this was based on was designed by lowtech.co.uk. That's where the original schematics came from. So yeah, this is marked EMS/ROM ISA board Rev 1 by HKZ. So HKZ, I'll post a link to the, I think it's on GitHub or GitLab or something. The Gerbers and things for this. And the driver, because he's modified, he's done the modifications to the driver that's the original company produced, a 2 meg one of these, yeah, and the EMS driver for that is needed to access that 2 meg. He modified it to support 4 meg, and this is why I went with this one, because I wanted more the merrier. 4 meg of RAM versus 2 meg, it's always a good idea. Now these chips can be pretty expensive, like £10 each or something. I actually managed to find a seller on AliExpress where it was, I don't know, about 20 odd quid for 10, so it's actually a lot cheaper, like £2 each or something. But as you'll see, if we get them out of here, I've got a load of stuff in here for this. Yeah, they've got the usual, shiny black surface. Some of them are more shiny than others. Some of them have got different indents and things. If you look at those on the light there, if I can get the right angle, you can see this has got like a circle and a circle, circle and a circle. That one doesn't. That one doesn't. So, like, are they fake? Are they, they've been repainted and stuff. The legs tinned, and this is the thing. So maybe the genuine, but they're from different, reclaimed origins, or are they just completely fake and not going to work? I don't know. So for that reason, I'm going to be socketing, putting sockets on these, and we can start, with 2 and just test. Do we have a meg? And then do we have 2 meg, etc. Anyway, I'm just going to fly through this. You've seen it all before so many times. So I think I've got all the 74 series I need for this. I've got some resistor arrays, different sizes on this, which is always a mystery to me why people do that. I guess it's efficiency in terms of just using what's required in terms of pin count. But you know what? If you're going to do a build, maybe just have a few unused pins, etc. And have the larger ones is the point, because then you can have the same size. We've got 3 different sizes used on one board, I think. Right, I found some sockets for the main chips here. Yeah, and those ones as well, the ROM. I'm not sure what you can do with that ROM. I don't know. You could put some sort of, I don't know, XTID boot ROM on there or something. But of course you need an interface. It's not got ID or anything built in. But these sockets, I've got loads of these, like a full drawer of this size. These kindly came from Colin and Nathan, and it's, Alison's old stuff. It's one of, these are sockets that Alison owned. I had some of these size myself, but Alison had a lot of these. And I'm guessing it's for Atari STs and stuff, and BBCs or something like that, maybe. But they seldom get used on my channel. I don't think I've used one of these out of this drawer in the last 3 or 4 years, really. So it's really good that I'm going to be able to fit these on here. And when I send one of these boards to Glenn and Barry, Sparks, I'll send them the sockets for this as well, because, well, I'll show you. I've got a tray. I've got a tray full of them. It's like saying I'm never going to use that many. So yeah, it will mean that the few of these boards that I give out, they're going to get sockets as well. If I've got any surplus ICs, I'll send those with those things for those guys as well. But I think I've pretty much got almost exactly what I need in terms of volume of chips. There's just a few spares. So, yep, I'm not going to bore you with all of this. So I'm just going to start by just anchoring top corners on each of these. And just anchor them all like this way. And then solder them all in one hit. It makes sense. You just save a lot of time. But also, you can, check alignment of these when they're next to each other before you haven't committed to solder them on to get everything nice and straight. So I'll report back when all those are on. Right, that's those just anchored in place. It's looking pretty good already, isn't it? Right, so I'm going to get one more on for the ROM. I'm not sure I'm going to fit the ROM. I'm not sure it needs a ROM for the RAM side of things. I think it doesn't, because I do remember on the GitHub or GitLab page, it said the ROM's optional. But I figure, why not fit it while I'm here? Because you never know, whatever PC I stick this into, I might need to add a ROM for something at some point, and if I've got this board in there, it's it's just something dealt with. And I might test that out within this video as well, but the main focus of this video is to just cover building this and testing it. A couple of things we can test this on. I've got Monotech Nuxt NUXT and XT PC. We can add some RAM to that. I've also got the 286 board in the Amiga and a 386 board, so I'd be interested to test it against each of those things to see if we can add some EMS RAM. And before I do the sockets, I'm just going to get some of these resistor arrays on. So I've got a dot on this resistor array there. It says there 10k bust, and we've got 6 pins. So yeah, this is one of the different types. We've got a 6-pin array here. If we just get that through the hole, or through the holes, yeah, just flip it over, put a bit of pressure on it from the other side. Maybe just solder one pin and then just inspect it to see how straight it is according to where you want to position it. You know me, I like to get things nice and straight like that there and equidistant. So yeah, that's exactly how I'm going to fit that, I think. Got another 10k bust resistor array there. So this is the larger one, again a different size. I think this might be 8 or 9 pin, I'm not sure. So again we've got pin 1 marking there to the left side, and it's marked there to the left side. Hopefully it's the right size. Yep, perfect. So let's get that on. Pass that on. Yeah, this end here needs to come to the left slightly. Yeah, there we go, so not too bad. And it's only taken me about, I don't know, less than 10 minutes to get to this point. Right, just some of these smaller sockets now. And then we just got resistors, jumpers, caps, Yeah. Most of the caps on here are just going to be 100 nanofarads, so it's going to be pretty easy to finish this build off now, I think. I know in the past I've said don't solder the VCC and ground. If I am, and I think I am doing that at the moment, it doesn't really matter because we're not reworking a board here. It's really easy just to heat these and move the chip. And of course, do make sure all the pins are all through. Yeah, none of them are sort of pushed up out of the actual socket before you start to solder them. Yeah, so just a load of 100 nanofarad caps, some jumpers, more 100 nanofarad caps, jumpers, an electrolytic. We can go with whatever we want here. I mean, it does say 10 microfarad, 10 microfarad, but you know, 22s, 47s, 100s, it's not going to make much difference really there. There should be a few resistors actually. Oh yeah, some resistors here. In fact, those might be resistors. No, they're caps. Yeah, so just 2 resistors, those are 10k, so a really simple build, isn't it? I mean, there's a lot of solder points on it, but it is a really simple build. So I got the strip of 7 jumpers there, that's actually 14 pins in total, and I just cut it. I cut it off this excess piece I had here, and you can see it's got a bit there broken. We just need 4 on this side, so this is going to be, hopefully, just the right size if I can trim off that little 1 pin. Let's just carefully do that. Yeah, and this is where I did this on that piece there. I just used the file just to smooth off any burrs, any bits that hang over the edge. Yeah, that's not too bad actually. So yeah, short side through the holes here. And just hold it into position gently. Don't put pressure on the pins or you may move them because they will melt the plastic when you heat them if you heat them with too much heat. Make sure it's straight. Yeah, and that's looking pretty good. So I'll just commit to soldering one of the other pins. And then just press gently. Yep, there we go. So loads of solder points. It still looks like this chip here is coming down a bit on that side. I think it just needs lifting up there, that way, marginally. Yeah, that's it. That's looking straighter. And I did just adjust that one slightly as well. Yeah, so the 100 nanofarads I think I'm going to do next. Finishing off the ceramic 100 nanofarad caps here. And you know what, I took a gamble on just putting 100 nanofarads. I haven't checked the parts list, the bill of materials. And I was thinking about this, the electrolytics, because there's only 2 on this whole board. And the Mark 10s, I'm going to uprate those. Actually, you know, 2 10 microfarads here. I don't think that's enough for the amount of RAM and chips that are on here. I may fit like a 47 and a 220 or a 47 and a 100. And the reason you have different sizes is to do with, well, when it comes to filtering side of things, there's a benefit to having different capacitances there. It deals with different frequencies. I mean, the author, you know, the designer of this did say, you know, there are some issues with some PC compatibles that he found. Some stability issues and things like that. And that's perhaps what some of the issues may be. Yeah, so there's still a batch here. I mean, I could put a slightly different size there. Instead of 100 nanofarads, I could put some 220s or something. The point is, with things like this, you know, people get a bit nervous about these capacitors. Oh, you know, can I fit this? Can I fit that? Oh, is it going to be alright? And it's like, some of it is just suck it and see, you know, trial and error. So, and some of it, you can do some speculative guesswork yourself based on what you think. So like, I could just fit some, and I might just do that, instead of the, because I'm getting low on the 100s here, I might just fit some 220s there instead of 100s. Nanofarads we're talking about here, by the way. Surprisingly, I don't have any 220 nanofarads in that type of package. I've got pretty much everything bought. So I'm just going to have to use the remaining ones of my 100s here. Yeah, and if you're thinking to yourself, well, how can you guess that 220s might be alright? Well, just look at anything in the Amiga range, systems that run sort of these sorts of frequencies and things like that, doing similar kinds of jobs. And across all the Amiga boards, you'll see a variation of 100 nanofarad caps. Sometimes they'll use 220s, sometimes you use 330s. And I don't think there's any, I mean, I could be wrong, I don't think they've scientifically calculated some of those things in some places. Other places they perhaps have. One down, about 7 to go. Yeah, that's a good location there to get another size actually, rather than 100 nanofarad. Get a, you know, like I say, a 1. We could have a 1, a 47 and a 220. And like I say, and if you're not understanding that, it's like I say, different, when it comes to AC, yeah, different capacitors. You know, the size will target certain frequencies, and that's what will happen. You can bypass any noise, that AC noise that may be picked up on the board. Yeah, AC passes through a capacitor. DC is blocked by capacitor. What am I doing here? Yeah, this one over here. Yeah, so there is mileage in just a few different sizes if you can put them on the board. And you know, it's the same thing with the resistor sizes. You know, this is saying 10Ks. You can get away with 4K7s, I'm sure. They're just going to be like pull-ups. It really is that simple. So you don't always need the exact matching bill of materials. You can use some odds and ends, and you can economise where you want to and change things slightly, and I'm sure it would be alright. So I think that's all the ceramics now, apart from obviously there's one marked here, C8 I think it is, or C0. We need 2 10K resistors, but I'm going to go and get the electrolytics now I think. Right, so I am going to go with a 1, a 220 and a 47. So I want to try and find the smallest ones I've got here. Oh, I've got some 47s here, these are Panasonics. So the ground is to the right here, isn't it? Let's just check that. I'm sure that's correct, but and we can test that ceramic there as well. So we're on continuity test here. The 74 series ground is there on that one. Yeah, so there we go, yeah, ground on the right. It's a good thing to do this, check for shorts as well before you power it, certainly. And the ground there is at the top. So let's get this one first, ground to the right. Yeah, this is one of these ones where it's like that. I can't remember the term for that, what it's called. Spread out. So I'm just going to squish them in. And get that on. Obviously, if you use too big a capacitors, it could cause a problem with the thing that's, you know, sat next to it. See if I can get that flat on there. There we go. Yeah, so I've got a pretty small one here, and ground was towards the top. Right, there we are with all the components on. Again, odds and ends resistors, so those are both 10K, but they're obviously a different package there. Now we've got a 220 and a 1 and 47. So yeah, the final thing now is to get all the chips in, but won't do that until we've soldered all of the solder points there. Using the fume extractor here from ZX Kim 81, who's no longer with us. I know you hear me say these things over and over and over, but it's what I think when I'm doing these things. You know, I look at my solder head, and I think of Dermot Sweeney. And it was a comment Miss McLennan made on one of her videos actually that reminded me that I really should talk about these things more when I think something. And I did. I think I should use the fume extractor. It came from ZX Kim. Yeah, so about an hour and a half in total to, you know, get to this point from the beginning. So yeah, we're getting there, aren't we? We're sort of like 3/4 way done here. Just need to do all these smaller profile chips now. Yeah, so I've been sort of whizzing along these really, and then just giving them, you know, a second reflow at the end. It's hard to get that soldered. There we go, just in the right place, so you can whiz along like that. Woohoo! I'll say it, every single solder point soldered. So the only thing we're lacking here are the components, a resistor for the LED and the LED, but I'm not going to fit that just now. I don't actually think that's needed, really. I mean, it says ACT, so it's an activity LED, so you know what, when that's there, you may be able to see activity of the RAM. Anyway, I'm now going to get the chips on, I think. We'll clean up later. Yeah, get the chips on, just wipe this with IPA, get some jumpers on, and go and give it a try. So I'm going to get another one of these out just so it makes it a bit easier to actually read the part numbers because they're under the sockets. I mean, you can see them technically. These sockets are pretty good actually, those top ones, they're good quality, and the way I know that is it's got this strut in the middle. Most modern sockets these days don't have any middle support braces. Yeah, so let's start with the RAM. So yeah, the bit splayed out, so we can use the leg straightener here from Cathers and just gently try and straighten these a little bit. These are definitely reclaimed, so I don't know, I've got this bad feeling about this. Yeah, the legs are still a bit bent outwards on them. That's it, there's one in. Yeah, this RAM's made by Alliance, by the way. I guess what I should do is just do these at a pair at a time, so let's just do those two for now. Yeah, and the HC04 is the first small IC there. Again, legs are splayed out because it's brand new, this one. Right, so we just need the 74ACT245 and some jumpers. So I'm going to test it in the A2000 here to start with, so it's in the slot here. I've got the jumpers, there's just 4 pins you need to set, 4 jumpers, actually 2 set, 2 of them on. And I'm just going to power it on, put my hands over this chips here. Just make sure nothing's getting red hot, and it isn't. And then I also need to see, is the Amiga booting? I'm just watching the LED here. It's strangely enough the Amiga isn't booting. Maybe it's stopping the PC side from booting. Having said that, it shouldn't be booting at that point, should it? It's like, why no activity here? Yeah, stepping through the motions here, it's a power related problem. I have had this with this darned ATX adapter here. So I'll spray some contact cleaner in that in a minute. And the reason I know that is because I removed the other card and I was getting green screen. When I see a green screen on this, and it happens on all these 2000 boards here with this adapter, it's always the power. If I measure the voltage, it'll be like 4.6 volts or 4.5. But you can see that's booted up. So yeah, we'll just get some contact cleaner into that. Then I'll boot it with the bridge board again. Make sure I got all the pins there. I got most of it on my fingers, look. Slide forwards, backwards, forwards, backwards, forwards, backwards, like that. Just power it on to make sure I get no green screen. Yep, no green screen. And then we'll carefully just get the bridge board back in. The Zorro slots are super clean because I spent some time going through every one of these slots on both boards, actually both my test boards here. Yeah, it's booting again. So that should hit the IDE any second. Yeah, that's all it was a power thing. So we can get this back in again. And to start with, I'm fitting it in the end slot. I haven't got VGA. There we go, it's such a loose fit that I actually don't like how loose that is. And I'm just going to power it to see if it boots. Yeah, it's booting properly now. I'm getting the rainbow coloured bands from the 536. Hopefully we should see some activity there in a second. Yeah, that's booting. That's it. So we've got the VGA card in, and we can get the sound card in after we've maybe got the RAM working. So I'll power cycle it again. Well, not really power cycle it, power it on. Yeah, and here's that power issue. Look, this is the thing. So I'm drawing so much power now that the voltage drop from that connector is causing me a problem. There we go, just reseating it, seems to have solved it. Yep, there we go, that's booted. And I heard the PC boot. Right, so the PC side is booting. I actually need to go into setup here, Control Alt Escape. Yeah, the reason being, because of floppy drive configuration error, I actually disabled it and then I've connected one up because we need to use the floppy drive to get the memory manager driver on. Anyway, if I do Control Alt Escape, I'm going to change that to 1.44 and then end. That should reboot, and all being well, I can copy the driver off the disk. You can use USB floppy drives on Windows 10, but what you can't do with a USB floppy drive, and I've mentioned it lots of times in annotations, I think, you can't write a floppy image to it. So if you get specific software, and I don't know, run DOSBox or something to try and use that USB drive to write a raw image to a floppy, you end up corrupting, if you're not careful, corrupting other drives in your system, like your C drive or your, another hard disk, for example. Because of the way it works, it hasn't got direct control over the things it needs to be able to write a raw disk image, but you can copy files to it without an issue. You can format a floppy drive that way as well. Anyway, if we go to A, and it's reading it, there it is. So as I said, this is the hacked version that I got from the GitHub there that allows 4 meg. So I'm going to do xcopy star.xc, and I'm going to put it in C / and I'm going to call it EMS card. Directory. There we go. So if we go to C, cd EMS card, there's our executable. So LTHCK. Let's just see if we can see any switches or anything for it. Yeah, we can. So, right, the page frame address. I mean, it's set to E000. That's what I've gone with. And I don't know whether that's going to clash. Is that going to clash with something else here? I don't think so. Yeah, I'm just going to take a photo of that, and then I remember what the file name's called, and I remember what the switches are. Right, so after HiMem, let's stick it there. C colon. Yeah, I am using an Amiga keyboard, so I'm not that used to using it. EMS card / and it's lthck.exe / p colon E000 I:268, and I think that's it. I think that's what we're going to go with. We're going to go with just accept whatever the defaults it has, because those are the only two things that I set. Right, let's do Control Delete. Let's see what happens. Please work. I really don't want hours of trying to work out what might be going wrong. And of course, this might not be the best choice of PC to test this in. Non-system disk. Oh yeah, I've got the disk in the drive. Oh. Please work. Please work. Give me 2 meg. Oh, sorry, it'd be 1 meg, won't it? Give me 1 meg. Installation failed. No EMS available. Well, that's not good. Right, so I think those RAM chips are fakes. I did suspect that, didn't I, when I got them out? I'm convinced they are now, though. And I'll show you in a minute. Some acetone on the top, the black paint comes off. You can't see what's underneath because they've ground them down, shaved a certain amount of the surface off, milled it off or something, and then just, put a new fresh surface on there and stamped them with fake part numbers and things. So I think they're actually another type of chip. They all fail the same way in the TL866. It's not like it fails at a different address or a different data bit. It just goes all the way along the progress bar, gets to about, 70% of the way along, and then just goes error 31, device read error. And every single one of them do that. Well, I did consider maybe they were half the size they're supposed to be, but you get exactly the same error. So I don't think so. I think it was just a completely different type of chip. Anyway, cleaning this up now. And Sparks UK is currently going to do a DigiKey order. So instead of the £20 I paid for these for 10, it's something like £4 something each. So it's like 40 quid for 4 meg, which is ridiculous, but that's how much they are. You just can't seem to find them cheaper anywhere else. So it's a bit of an annoying design, really, that we've got these RAM chips on here that are roughly £4 each. There must be a better solution. I was thinking maybe there's a 4 or 8 megabyte SRAM you could fit onto this with a redesign, and then you wouldn't have all these sockets and all these chips. Just have one single chip. Yes, you've not got the single, the individual chip selects for each one, but that can't be that hard to work around, really. in terms of a logic change. Anyway, I'm going around random order here, aren't I? I was doing that one. I'm just going to work along the bottom side of the board here first, I think, and I'll get the toothbrush onto it. Yeah, so we've ordered some new ones. Well, I think we have. And we'll try it with some new known good working chips. And the thing is with this, it's really annoying because, you know what, I've lost 20 quid. Can't put a complaint in on AliExpress because these were all ordered at the same time, the RAM and the boards, and the boards took about a week and a half, 2 weeks longer to arrive than the RAM did. And because of that, the window to complain on AliExpress automatically closed on its own. It's like, this is what I hate about AliExpress. You don't even have any, you know, way of putting a complaint in, you know, a month later after having received it. You can argue, yes, you should be testing it within 24 hours, but that's not how things work. This don't work like that way on eBay. On eBay, you have like 3 months or something to be able to put a complaint in, you know. So yeah, I don't like the way AliExpress works, and for that reason, I won't be using AliExpress again unless I can't find the part anywhere but AliExpress. If it's more expensive elsewhere, I'll go elsewhere. It may be easier and quicker just to stick this straight into the ultrasonic and then use the toothbrush in the ultrasonic. You know what, I think I might do that actually. I might just put it in the ultrasonic because I've got loads of IPA in there. Toothbrush, and then switch the ultrasonic on just to rinse it off. There's nothing else on there that could be negatively affected by the ultrasonic. Yeah, so I'll do that. I mean, you can have a look at it now and I'll show you the difference in a minute. There's lots of flux around here, look. So the first thing you might expect is maybe a bad RAM chip. So I swapped the RAM around. I tried all of the RAM chips in the first 2 positions and just not working. I've got a question mark on this one at the moment because, yeah, long story short, one of them is faulty, as you'll see later on. You can see that? Cobbles going black. So yeah, they're painted, which is what I suspect is right from the start. And yeah, the more you do this, obviously the more of the print wears off, and eventually you get to the point where you get through the paint. There you go, you can see it's like browny there, look, blacky brown. And yeah, there's no other identifiable stuff going on underneath because they'll have been milled down. Yeah, but anyway, that is not normal. On a genuine chip, you wouldn't get that. The other telltale sign is solder code pins. On a genuine chip, if you get one of these from DigiKey, they won't be solder code, those. They won't. So with regards to this not working with the A2286, come back to that in part 3 of the A2286. It's kind of more relevant in that video, some of the stuff that I did there, than it is in this video. But I'll summarise later on in this video here what the actual general issue is. Well, whilst it having sort of fake repainted chips on, it does actually work. I've actually got a megabyte working here. The first megabyte I've just come to test, and this is in the 386 with the 386 card on the Amiga. So the 286 is not working with it, and I suspect that could be something to do with the overclock I've got on there. It's running at, I think, 11 point something megahertz instead of 8, so maybe that's the issue, because it might be overclocking the ISA slots a bit. But also it's about how the data bus is buffered and how the address bus is buffered on different cards. You know, they've done different ways here, but this is working. I've put it on a long test here. It's doing all different things on the EMS RAM, and as far as I can see, there are no errors yet. So I'll wait for that to complete. If that works, I'm going to install the other 6 meg and test that out. But it would seem to be working. Now that means the TL866 diagnostics there, you know, for testing SRAM, doesn't work on mine. It may need the newer TL866, because there was a TL866 and TL866 Pro, I think, or something like that. And that might be the thing. Yeah, the software doesn't support my programmer, you know, the latest versions and things, so I'm stuck on the version I'm at, but I'm really surprised. Really surprised. I mean, I don't actually think that this is even Alliance RAM, yeah? I mean, you can see there, that is where I put acetone on, yeah? So they have been painted, every one of them has been painted. They could be like Hitachi, you know, like 6, I don't know what the part number is, like 6425512 or something. There's a few different other similar part numbers, and I wonder if that's what they've done. They've got some old stuff off some boards, some Hitachi chips, and then branded them this way. So they're not going to have the same characteristics in terms of speed, but I don't think we need the 55, because I think those Alliance ones are fast, aren't they? Like 55 nanoseconds or something. I don't think we need that on an old 286, 386 or XT. There we go with the slow long test. That worked. So I don't know, I'm really confused as to why it doesn't work in the 286. Right, I'm going to what I'm going to do. I'm going to get a sound card in, I think. I'm also going to get the rest of the RAM in. We'll test the full range, but then I'm going to test some games that use EMS RAM. I think Aladdin is one of those. Right, so all 8 meg are in. Here's the boot process. Ignore this count here. This is extended RAM, and I've got 8 megabytes on my board. Sorry, did I say 8 megas in? 4 megas in. There's 8 chips, 512K each. So once it gets past the, in fact I think I commented HiMem now actually, I might need to put HiMem.sys back in for the extended RAM, but you know what, I want to test it without that, because things like Wolfenstein, you know, use whatever RAM you've got. Let me just get rid of the floppy drive here in a sec, because this is expected a floppy drive, again like the other one was. And at the moment it's disconnected, so going to setup, I'll just get rid of, hang on, where's it gone, there, the floppy drive, and click end. Yeah, so as I was saying, Wolfenstein will use EMS if it's available, rather than extended memory. So the fact that HiMem.sys is commented out in the config.sys should mean that the only RAM we end up with after a boot, if it's working, is 640K base and the RAM from this 4 meg EMS board. On the 286, this just went straight away. It's actually testing it properly though, isn't it? Now I've got the long test on. This might be why it's taking forever. I think there's 255 pages on there, if it's seen all 4 meg. Well, that's an interesting bug there. It went Q something. That could just be a bug in the driver where the memory test is not outputting the right thing, because there are now more pages than there were originally. I bet that's what that is. That's just a bug. I might even be able to hack that bug out in the executable actually. I'm assuming, there we go. So it's found it. It's full. Found the full 255 pages. Yeah. If we're going to check it, machine check it, it's going to report 4 meg. Yeah, I think this RAM is older RAM. Relabeled. It's going to memory. So I'll do a quick test. Yeah, look down there, 4080, and that's exactly what you should get. It's not quite 4 meg. It's just a tiny bit under. So if we just do, I don't want to test the extended though, because it's still detecting that, even though the HiMem thing's not loaded. We'll do change, hang on. So 0 to 0, 1 meg to 1 meg, and then 0 to 4 meg. Quick, yes, 1, yes, yes. So that's just going to fly around the expanded memory now. Let's just see what it comes back with. Expanded memory is pretty slow compared to extended memory. Just wondering where it shows you any errors. I think the tick, you know, that first tick there shows the first meg was alright. So if we get 4 ticks, then in terms of a quick memory test, it's saying everything's alright. I don't know, I'm blown away. I thought I was going to have more problems with this, and I honestly believed that RAM was the problem. It could be about ISA slot termination as well, because in the wiki for this, you know, the actual GitHub page or whatever, the author of this particular card did say he had problems on certain PCs, and I think he said he used an ISA slot terminator himself. So I presume that's like a bunch of resistor arrays on, I don't know, data lines and address lines and control signals and things, and you stick it in the far slot there just to help terminate the slot. So it's doing EMS verbal. I don't know what that is. Does it mean verb as in version? Past. There we go. So let's just come out of that. Right, we've got no extended memory. We can actually test that. Do mem/c/p. Anyway, let's just go into some, I don't know, Wolf 3D. So that should be reported down here somewhere. There we go, look at that. We've got a full chunk of that. XMS, yeah, it's XMS we don't have, because you need to use HiMem.sys to get XMS. Yeah, that's right. So if that works now and it's nice and fast, that shows it's using that EMS RAM. Well, I say nice and fast, it might actually be slow, I don't know. I mean, this is a 386 running at 25 megahertz, so I wouldn't imagine it being that slow actually. Chapter 1. Yeah, it's a bit slower there. That shows me that it is using that EMS, because EMS is slow. If we were using XMS now through HiMem.sys, that would have shot along there. Yeah, I mean, that is really slow, actually. So slow. Interested to see how that actually affects the gameplay here, because we may find it's really, really slow now. And then you've got to question, what's the benefit of having an EMS memory board like this? Certainly in a 386. You see, in the 286, we haven't got any choice, can't get any other type of RAM in there. You know, there are no SIM slots, we can't even do a modification to the board. Yeah, with a little pause there. Oh. It's actually not bad. Yeah, there's the odd little pause that perhaps didn't happen previously. But you know what, you wouldn't notice, other than the delay loading, you wouldn't notice. And I guess that's because once it's loaded, you know, it doesn't need to pull much data back from that RAM as it needs it. So, you know, a bottleneck there. Yeah, you might not notice it too much. Yeah, there's just the odd little slowdown occasionally, but you know what, that's pretty darn good actually. Right, let's come out of that. Well, second reality, that needs XMS as well, I think. So if we do second, yeah, so again, normally you need EMM386. Yeah, you turn some of your extended memory into EMS memory. It's taking its sweet time loading that, that's for sure. Yeah, here we go. So I'll change it to Sound Blaster Pro Stereo, high, and then just press return. Normally that'll bomb out if you've not got at least, I think, 1 or 2 megabytes of EMS. Yeah, so it's slow, I think. Is it? I don't know. Why is the screen black? Maybe it stays black for a period of time. Yeah, I may have shown this before on the 386 card. You do get that odd pause and the colour goes a bit strange there. I might need like a VESA driver or something in the autoexec.bat or something like that. It's something to do with the VGA card I'm using, that little glitch of colour. If that's working. I mean, you saw a little jerk a second ago there. I think that's, yeah. And this is that VGA card, I think, in terms of, you know, not the best support with this game, this demo, not game. Yeah, so just ignore that. I may try the other trident on this to see if that problem's solved. So slow. You really need a 486 to get the best out of this demo. So slow compared to XMS. Well, when XMS is converted to EMS. And my favourite bit of this, it's going to run pretty slow though, I think. Yeah, and again, we've got like a, you can see like a ghost left behind where it was. That's just that graphics card, I'm sure. Anyway, let's quit out of that if we can. Let's press escape. I'm really pleased with that though. It is actually working. Yeah, so we've got 4080 there. Hang on, it's at the bottom, isn't it? Yeah, 4080 of total expanded memory. That is really cool. So I guess we should also switch off the slow check of that RAM, and then we might get the right amount report, because at the moment when it does that it counts up and it goes a bit weird, doesn't it, on the page count. Might even try and modify that in a minute actually, so it's fixed. Just go and put it in a hex editor and a disassembler, and we might be able to work that out. Yeah, the /x on the end there. Yeah, because it's now supporting 255 pages, you see, I think what's happening is when it gets to 128, it's going a bit nuts. They can't, they didn't, whoever modified it to support 4 meg instead of 2 meg, but then forgot about that memory test. So that's why if you do the extended, Control-Alt-Delete, if you do the extended memory test, when it got past, let's say, page 128, the hex that was displayed there, the text actually went a bit weird. I'm trying to think why that would be. It would make sense if it was more than 255 pages, because you'd be going over a byte. They must have used like a signed integer or something for that. That might be how they've done it. So used a signed integer, so you're going to have like 0 to 127 or something like that. And then when they got past 100, well, when they got to 128, it goes nuts. Oh, it's doing it there, look. So they've got the same problem there, even in the fast test. You can skip that memory test as well, that's one of the other switches. Anyway, yeah, there's not a lot more we can do really, we know it works. The other one is packing time, that needs EMS RAM. This is another reason why, hang on, this is another reason why also it's worth having XMS and EMS. Now I've got this board, in theory, I could use both. It's just pack, I think. Again, it's going to be a wee bit slow loading. There we go. I'm sure Mindscape got into hot water with this game, because they changed it, didn't they? On every other platform it came out as like something to do with flunkies or something. It wasn't nothing to do with Pac-Man. Yeah, that was so slow at loading. Yeah, got PC speaker sound there, haven't we? Anyway, definitely works fine. Not sure how you get up there. Anyway. You can see I fitted a blue LED and a 560 ohm resistor there, and when there's activity going on that flickers. And actually the game is running at the moment, and that LED is flickering all the time while it's just sort of sat here like this. So it's actually using it. You'd think it'd be using the XMS first, but actually it's super fast, super fluid. I've got the sound card out at the moment, But nevertheless, it is working. The LED works. It works in this 386 board perfectly here. I've used it for periods of time without any issue. When I say periods of time, I'm talking like, half an hour, an hour, etc. And no issues. But the A2286 board, I just can't get it to recognise any RAM in that board at all. I've done all sorts of things. I tried copper tape in various places. I tried adding pull down resistors on various control signals there. The IO read-write signals, mem read, mem write, the data bus. Tried different logic families on the various chips there. So the 245 swapped out for, because at the moment it's a HCT. I tried an F245, an ALS245, an LS245. HC245 did exactly the same with the 138, the 139, the 04, the 32. The only thing I didn't try is different 573s. I think the 573s on this, aren't they? Yeah. So I don't know what the issue is. Don't know why the 286 just doesn't like it. Which is ironic because I ordered it with the idea of using it with the 286. It works with the 386. So I mean, this 386 has now got 12 meg of RAM effectively, which is not a bad thing, but as I say, I don't really want to use it with the 386, I don't think. But you know what, I think if I was going to use either of these boards in my main 2000 and actually play games on it, which I will do, maybe the 386 is the better card stick in there anyway. So maybe I could just put this RAM board alongside it. There's a secret, takes you to a secret level, I think, or a shortcut. I forget where the other door is, that one? Yeah, there. It's like two secrets in a secret place there, hang on. Look, hidden lift. Yeah, loading the next level. Yeah, and you can see it flashed there, then it's just sat there in the game now, so I'm running around, you can see it flashed away. It's really cool, that blue LED. I went with a rectangular one rather than a round one, just because that's the only one I had in blue. So running the diagnostics that comes with the original low-tech cards, actually the 2 meg variant, or 2 meg version, the original version Ancestor. So it's only testing 128 pages, and this is a clue as to why we got a page of 16k missing, because it's using a byte there, isn't it? It's going 0 to 128. 0 presumably means you've got none. So it's 1 to 128. So as soon as you get to 255, it needs to go to 256 to get that last block. Well, you can't have 256 in a byte. So that's where it would overflow to 0. You could just test the overflow flag maybe. It would need a change to the code to do that. I've had a look at the assembly for this as well, for the original driver. So it's all there, I just can't get my head around the ASCII hex, or I think it's hex to ASCII function. That's one of the things that might need change, but also it's actually in the detection rather than the actual display. You've got two issues. One of them in how it displays anything over 128, and the other one with, that missing page really. Yeah, anyway, so I'm testing this on the 386 card like this. I'm going to try and do the same thing on the 286 card, but I'm guessing if it doesn't detect any to start with, then this test won't do anything. I don't think the diagnostics here, there's a few different tests here, I don't think that's going to reveal anything as to why it doesn't work on the 286. Right, so I copied the drivers onto the compact flash card on the Nuxt. This is a Monotech NU-XT, new XT. You may have seen this in a previous video where I got this board up and running. It just needed a firmware, flash to get, XT IDE working. So it boots from the compact flash card. I left it set up that way with DOS 6.22 on there, and a load of games and stuff. Many of the games are targeting a 286 or 386, but nevertheless it was just a copy of whatever I had set up already on another compact flash card. So now we've got those drivers set up, I can do exactly what I did previously. So let's do File, Save, File, Exit, Control-Alt-Delete. And the card's obviously plugged in, so let's just see what happens. So we've got a BIOS extension there, F000. Oh, hang on, it's working. It's working. So we didn't have this on the 286, did we? Exact same glitch there with the counting, just because of the hacked. Another Monotech NU-XT, new XT, full 4 meg tests out fine. So when I mentioned earlier on, it's a bit of a loose fit. yeah, it's about the thickness. Actually, I went with the default. Now, and this is the thing, I'm honestly not sure. Can you change that in the gearbers? I don't think you can. I think you choose at manufacturing time. So the thickness I went with was the default, which looks about, I don't know, 1mm, something like that. I think it needs to be about 50% thicker, or even maybe twice as thick. It would be really tight, but certainly 50% thicker. So yeah, but there's nothing wrong with these. They work really well. You know, it does hold in place, good connectivity. It's just if you put another one in, it's like really stiff and firm, and you know, it doesn't just wobble. You stick this in, you could move it a little bit that way or that way, and it makes a connection, obviously. But yeah, so that's something to consider. The other thing that I'm not showing within this video is you can see these two holes here. There's a mounting plate, and you can order them from DigiKey. They're only a few pounds each, I think. So I've ordered some of those. Sparks has kindly offered, actually, so he's added this onto a DigiKey order. So when you see this card, you know, the fully assembled version in a future video, hopefully I'll be able to show you that plate, but yeah, missed that out here. Right, so I have it working, well, ish. It's going to error, I think, on this block here. It's working now in the 286, and the answer is, well, me no likey. I don't like the answer, I don't like the reasoning, and we do have an additional problem in that the second mag here is probably going to fail, maybe. And it gives a parity error, and I'm like, parity? There is no parity. Well, there is on this 286 board. So, I don't know, and I think that's a red herring, to be honest. Because, yeah, you see we've got a cross there. That didn't work. But the first meg did actually work there. And I had to move this into a different address range. You know, we've been testing at E000. And therein lies the issue, E000. This 286 board has got two chips here. The 386 board, I don't know whether you saw that, we'll cover that when we look at the 386 board video for the Amiga here, the A2386. It's got one ROM, and I'm like, I noticed that when I was working, I'm like, how has it got one ROM? And it's because it's 8-bit, yeah? Those are two 8-bit ROMs, you've got 16 bits wide of ROM space on here. On the 386 boards, you've got one 8-bit ROM. And you're like, how does one 8-bit ROM work on a, you know, a 32-bit 386 that has probably a 16-bit data bus? It might have a 32-bit data bus on there, actually, thinking about it. And it's reading it in two halves. Yeah, it reads it twice. Yeah, you know, it reads a byte, stores that, reads a byte, etc. That's how the 386 works. This doesn't. This reads a full 16 bits spread across the two ROMs at the same time. And furthermore, the address decoding for that ROM space at F000, it goes back to E000. It's a 128k block of address space that it decodes on. Yeah. So in other words, when we set this EMS card to E000, this card, when it addresses that address, it goes, oh, hang on a minute, my address decoding is kicking in, it's like the ROM, I'm going to address it in 16 bits wide. So it's expecting a 16-bit ISA slot rather than an 8-bit one. That's why it wasn't working at all. Now, having removed the VGA card that sat at C000, we've got C000 spare, so I've set the EMS card to that, and that is how it's now working. I had to use on this here, because we don't have a graphics card, I've, you know, set it back to use the emulated, in quotes. It's actually hardware emulation, so it's, you know, it's hardware replication really of MDA or CGA. We were just using CGA there, and it sits at a different place. It doesn't use that space that the EMS card can now use. Anyway, so that's the situation. Now, that RAM error we just had a minute ago is just a new complication here. Hang on, it's colour one, isn't it? May need to reset it. No, look, it's booted. Yeah, so we've got another complication in the sense that the RAM flaked out a minute ago as well. I've been looking at the schematics to see, is there anything I can do? Can I modify the address decoding there? Is it done by one of the gals on there, or pals? You know, can I get the JEDEC for that? Do a modification to it and change the address decoding. Can I do a modification by changing a few address line wires around somewhere on the address decoding, or is it done in one of the customs? And the answer is, I'm not sure at this stage. Actually, I spent ages trying to follow the MEM16CS signal from the 16-bit slot there to the where it goes. I can't work it out. I can see it going into one of the gals. I can't see where it's produced at all. I must have spent 20 minutes looking at the schematics trying to make sense of it. So I'm skipping all the standard RAM here, and we're just going to test 0 to 480k there. Just run that again, just see, do we get any further on that, the second megabyte there. Of course, we could just revise something like this, redesign it for a 16-bit slot. And I think if I was going to do that myself, I would change the RAM type completely. And maybe just, you know, go, the sky's the limit. You can have, I think, is it 32 meg of expanded RAM? Yeah, you can. I'd go with a 32 meg chip or something. Look, it's failed again, so we do have some additional problem, and it gives a parity error with that specific memory. The first meg's alright, the third meg's alright, the fourth meg's alright, the second one's got a cross. And if we go down, it doesn't tell you how much. Oh, it does, it tells you there. So, 3.98. So the 4 point, hang on, I'm confused now, I don't know what that's saying. But anyway, if you look at the results here, so we scroll down and get the results here. Yeah, parity stuff, look. What's this all about? What does it mean by parity? I think it means parity in terms of the actual testing, rather than, it's not like actual parity. You know, it's like software parity. It's not an actual parity error, because that RAM is not subject to parity. Right, so I've swapped those banks around there. I'll be very, very, very surprised if this makes any difference at all. I'm calling it now as that's just going to be the same as it was. Yeah. Now the next thought I had, I can put a weak pull down resistor rate on the data bus buffer. I can just like wedge it into the socket. We'll try that next, because that just might help with a bit of reflection, or, you know, a termination there on that, the data bus connections, and maybe that'll make a difference, because it could be about the bit patterns there. You get the right combination of patterns. Well, when you're on the second meg, the bit patterns might vary, well, they will vary from the first or the third or the fourth meg, yeah, using different bits to specify where that window is. And that's where you can get a clash where, you know, one signal being driven high in a very PWM type way, you know, on, off, on, off, on, off, on, off. The trace that's next to it, suddenly it gets a high instead of a low. Yeah, I'm not probably explaining that very well. You're creating a charge pump. That's the thing. When you get traces running next to each other, and the frequency that things run at, you can get charge pump type stuff going on, where you get parasitic capacitors, where one trace can drive another one due to, you know, insufficient ground plane, bad layout, etc. Oh wow, actually, I've moved them around. Look, it's followed. So, one of those RAM chips is a bit questionable. Oh, I'm glad I got some spares. Yeah, there we go. After swapping the first chip, it's now passed. Look, we've got the first 3 meg. So yeah, it was just an actual questionable RAM. I've written a question mark on that. And the reason being is, like I say, I can put that same chip back on the card, test it on the other boards, and it works. So it's a timing thing. It's just a timing thing. For whatever reason, the other two boards are a bit happier with that chip. And the other two machines, I mean, you know, PCs. Anyway, hopefully that'll give us another tick here. Yay, full bill of health there. So I've only got one RAM chip spare now. That's a good job I got those spares. So just revisiting the memory map here, this is what I did in advance of changing it to C000. Yeah, the EMS page frame is there, look now. And I think the reason you have this 128k thing here, if I just go down a bit, system ROM, look, the system ROM's there, and I think this is like a 128k block of address decoding, yeah, comprising 64k, 16-bit, you know, wide. In terms of data bus access, that's the issue there. So, I mean, if it's not at C000 where it is now, we can't put it at D000. We can't use E000 because of the 128k thing, you know, 16-bit wide. There's nowhere else to put it, is there? You've got A000 there because the VGA card's not there. But you see, the VGA card had to come out in order for it to work where it is now, because the VGA card uses 2 lots of space. It uses some space for the ROM and some space for the RAM. So yeah, it's a bit confined, isn't it? There's a thing we can't even juggle things around here. What's that there as well? 16-bit high RAM. Oh, that's for the CGA. Yeah, normally these two wouldn't be here if we didn't have CGA. Anyway, we can't win. We can't actually win with this. So just having a quick look at the schematics here to see how this works. It's pretty simple stuff really. On the left hand side there you've got the ISA slot, and as we move further to the right you've got register address decode in the middle there. So that's a DMUX there, 74HCT139, and if you look to the left hand side of it you can see an AO write signal, so that's coming from the ISA slot through that 32 there, which is an OR, I think, isn't it? So there's another signal goes to that. I can't quite see what that is. And actually, if you follow that signal to the left, it makes sense now. P equals R. That is a magnitude comparator, the HCT688. We'll look to that on the SID card video. There'll be a link top right to that video. There's two of those. There's one at the top there for the ports, I think. It might be the base address, I forget which way around these are. And then one for the base address. Yeah. So, you know, the left hand side of those, you've got address lines going in, you know, some of the fixed address lines, and then some jumpered address lines, and that's what the jumpers are for. Yeah, so that P equals R, certainly the top one there, goes to the RAM select, so you know that gives you your chip enable or whatever it is on the bus transceiver there. We'll have a look at that in a minute, but basically as long as you've got the address matched and the port matched, then the hardware on this card will respond to reads and writes on the ISA slot there. But nevertheless, that drives the enable, I think, for that chip, and then you've got there's two inputs there, two address lines, A0, A1. So this is what this is doing. You know, you've got 2 bits coming in, 2 address bits, the least significant bits on the address bus there. And because you've got 2 bits, you've got 4 combinations, and those 4 combinations are on the right hand side there. So, you know, as the individual bit patterns change there between A0 and A1 for the 4 possible combinations, you've got 4 outputs of the 139 there that go through those buffers. They're inverted. HC04's no inverter, not, and those produce the reg load signals. So if we now sort of scroll across a little bit to the right to the data buffer section, so this is where those reg load signals go. On each one of these 74HCT573s, these are latches, 8-bit latches. Yeah, each one of those 4 signals, one for each of the 4 latches there, that helps latch the... Yeah, it is. It's the address. In terms of the left-hand side of these latches, it's data bus, D0 to D7 on all 4 of those latches. So the main ISA slot data bus is going to that side of the latch, yeah. But then the other side of the latch on each of these goes to the RAM address lines. So you've got RAM A14 to A21. So basically, the way the EMS driver's working, you know, you're going to be through the driver writing. So these latches to latch the 4 separate parts of the page. Now, this is the thing. I mentioned earlier in this video, I think it might be done in 16K blocks. You've got a 64K window, but that's split 4 ways. This explains it. And bear in mind that these 4 latches are all going to be driven independently based on how A0 and A1 are set, those least significant bits there on the address bus. So once you've latched your addresses here, right in a sequence of writes, maybe 4, I would guess, for each of the 16K pages effectively that this is going to be able to address, then the next part of the equation is probably the RAM itself. If we just have a look at the RAM itself, we can see on the RAM we've got data bus on the right side of it, DB0 through to DB7. That goes to the buffer, I think I saw that, I'll show you that in a minute. But on the left hand side, there you go, you've got those address bits, RAM A14, 15, 16, 17, 18, and you've got the main address bus going directly to that though, A0 through to A13, and this is an A9. Yeah, so there's 13 or so normal address bits go directly to that RAM. I mean, it looks quite complicated when you consider there's 2 different things related to the addressing of that there. But yeah, it's not that complicated. And in terms of that RAM, as I said, if we just have a look further down onto, it might be the other page, hang on. Yeah, I mentioned about the data bus buffer. If you looked at the bus transceiver there, that's a 245, it's marked down as LS245. I think I actually had a ACT245 on it, in actual fact. Yeah, so there's the left hand side is D0 to D7, that's your main data bus on the ISA slot, so the PC can read 8 bits at a time there from the RAM. And the right hand side, that goes directly to the RAM, I think. So the data bus is certainly buffered there, but there's no real buffering as such on some of the address lines, is there? Some of them just go straight to the RAM chips, and I think that's what the author meant when he said, you know, there are some issues there with a few things not being buffered. And the other thing we haven't covered there is the RAM chip select. So yeah, so there's a DMUX there, a 74HCT138. So this does the opposite of a MUX, and you can sort of see that, I think. If you look at the top left side, you've got the inputs A19, A20, A21. We've got 3 bits, and with 3 bits you've got 8 possible combinations. And on the right hand side of that, there's the 8 outputs, Q0 through to Q7, which form the RAM chip selects. RAM chip select 0, 1, 2, 3, 4, 5, 6, 7. So yeah, based on those 3 bits there, the bit patterns from A9 to A21 will dictate when those RAM chips each have their chip select low. Yeah, so the actual address decoding side of things is simple, but it's done by like a 2 or 3 step thing, isn't it? There's a few different things affecting the addressing of these RAM chips here. So yeah, on first inspection that could confuse the heck out of you, but you could simplify this. That's one thought I did have. If we could simplify it in a CPLD or something and do away with all these 7.4 logic chips. Yeah, so wrapping up here at the end of the video, came out really well. You can see after it went through the ultrasonic, there's barely a mark on that. It looks like a made one. Well, it has been made, but you know what I mean, like a sort of thing you'd buy from a shop. Yeah, so very pleased with this. It works really well in the 386 and the NUXT. Can get it working as you saw in the 286 there, and there's more about that in part 3 of the A2286. We will look at this again, perhaps in combination with other things we look at in future, because you know, on some systems where you only got like 640k base memory, that's not really enough to do much with, is it? You do need to add some additional RAM, and this is where an EMS card like this is super handy. So it's really good that this is open source. You can buy the 2 meg version from Lowtech. Usually you can get those on eBay, and there'll be a link down below to their web store. Or you could just go to the author of this product here and order your own PCBs, order the chips and things, and build your own. So how could this be improved? I think removing this RAM, because this RAM is becoming sort of more and more chance of obsolete, and it's roughly £5. It's like £4.60 or £4.70 per chip. Now the limit on EMS RAM, I think you probably need like a LIMS or 4 driver or something like that, but the limit is around 16 megabytes. But yeah, not everything is buffered, so you could consolidate the RAM into a single 16 meg chip. CPLD, small, I don't know, 96 pin job will do the job probably, something like that. One of those little Xilinx chips, replace all that logic, a couple of buffers there, perhaps still have room for a chip. You can have it as a flash ROM or something, that's a possibility. At the same time, because you're able to consolidate, maybe you could merge an XT IDE, have a compact flash interface somewhere and have 2 things on the same card. The LED, worked really well with 560 ohms, and blue went really well with this PCB. It looks great with that LED actually. And of course the other thing to consider, maybe make it 16-bit, because you're going to get twice the performance roughly there, potentially a bit more. I think with 16-bit, with 16-bit ISA slots, doesn't it go a wee bit faster? The actual speed might be the same, but the fact you've got an extra 8 bits here, it can read 16 bits at a time instead of like 8 and 8, 8 and 8. So you've got half the number of reads. You lack that wait state, but it's a bit more complicated, I think, when you get to the 16-bit side. There's something you've got to do in terms of assertion timing or something. It's like it can be really difficult to do apparently. It's almost like you've got to flip a bit somewhere based on a change that's coming up somewhere else on another signal ahead of it. It's one of those. It's a bit I was trying to get my head around it. I think it's actually one of the chip selects on this, a MEM16CS or something like that. It can be a bit fiddly to work with, but yeah, I think 16-bit, 16 meg, CPLD, XTID built in. Oh, that'd be really cool, wouldn't it? And that's the sort of thing that, well, we could do ourselves. I might have a go at some point. Those projects are open source to start with. It's just the time, isn't it? So yeah, it's certainly something that I would like to look at some point in future. But there are other things that are sort of bringing the same sort of capabilities of this with lesser work, really. And what I mean is, again, there'll be a link down below if you can find it. You can do things with the Raspberry Pi now. I've seen a project with a little Raspberry Pi, connects to a 16-bit or 8-bit ISA slot, and then mouse interface with it. But in theory, you can have EMS RAM, you could have a video card, you could do all sorts of different things, or a sound card, all sorts of things with the Raspberry Pi, emulating, you know, and then using its GPIO to communicate with the slot. So you could argue that rather than have all the stuff I've said, why not just stick a Raspberry Pi on there and wire it up to a 16-bit bus and then just start to, you know, add all these wonderful things, really. Anyway, I do hope you found the video interesting. Please like, share, subscribe, and I'll catch you in the next one.